of log functions. Properties of log functions. So basically we have three properties plus change of base. Okay, so the three properties that I'm talking about, log in any base of a product, that's one, the product rule, log in any base of a ratio or quotient rule, and log of in base A, any base, A to the X, or let's say B, maybe better, constant. So this, if you remember, is the sum of the two logs. Log base A of A, log base A of B. Very important property, the product rule. Anyone remembers the quotient rule? Wild guess, what do you think?
Okay.
The same, but with minus. So log base A of the numerator minus log base A of the denominator. Very important property, the quotient rule. Last one, so this is product, this is quotient, and this is power. That power goes in front as a factor, meaning it multiplies log. That's what we mean by a factor. This is a factor because it multiplies, not adding or subtracting. So this is the property we have to use over there. This is the one. So coming back, I'm going to copy it again. We have natural log 2 equals natural log of e to power 0.045t. We are applying this rule. There is nothing I can do here. Natural log 2 is just a simple number. Using this property, how do I proceed here? What do I have to write? What do you think? Give it a shot. You may remember this by now from algebra. So I'm using this property.
Is it 0.045?
Exactly. 0.045 times t times natural log e. Because
so you break everything down, I'm sorry, not just
this is the power.
the whole thing. Okay.
The power is this. If you want to put parentheses to see it, that's fine. It's multiplied. I cannot separate them. So this goes in front. Now let's discuss natural log e. In case you forgot, we're going to look at the graphing calculator. Oh, where are you guys? Okay. All you have to do is just go to natural log and punch in e in it and close. They are inverses of each other. E and natural log ln means base e. So when I click enter, I will have to get 1. So natural log e is 1. Since this is 1, I will replace this by 1. So I have to find t. Can anyone tell us how to find t? This is 1. What should I write from natural log t equals 0.045 times t to find t, which is the doubling time for continuous compound interest? How do I write this? Don't forget, natural log is just a number. Natural log 2 is just a number. How do I write this? Anyone, please? Let's solve this equation for t. Please, anyone? everyone knows how to solve this equation for t. What will you tell me to write?
Divide by ln.
ln 2 by?
No. 0.045.
Excellent. That's it. Awesome. So let's calculate that. So we have natural log 2, close the parenthesis, divide by 0.045. And this will be the number of years for the $75,000 to turn into 145,000. 150,000, sorry. 15.4 years. So T approximately 15.4 years. So if we deposit $75,000 today at the interest rate of 0.045, compounded continuously, we will have to wait for 15.4 years to turn into double, 150,000. Any questions? Any questions for me? We reviewed a lot with this. Now I would like to show you the change of base formula. You can say I don't need the change of base formula because the new calculator has everything in it, so I don't need to remember that. I think it's a very useful change of base formula. Change of base. So remember, in the calculator we have LOG, which means base 10. We have ln, so this is common log, and this is natural log. What was the base again for natural log? What was the base for that? Yes, of course. Thank you very much. But what if I'm asked to determine, let's say, log base 7 of 1/3? I have no idea. But I can use either one because that's what I have in the calculator. You can say, yes, I know there is a way of putting the 7 in the calculator, but let's say we don't. Well, the change of base formula will help very easily. So you either write log of the number divided by log of 7, which is the previous base, or not both. Or you say, I don't want to use common log, I want to use base e. Fine. Then natural log of 1/3, which is from the number, over natural log of the base. They have to be the same. So let me share my screen. And we go to log 1 divided by 3 divided by log 7. And this is what we get. And if we use natural log, but they have to be the same, both natural log over natural log. Don't combine them or mix them, right? Natural log 7, the answer has to be the same, identical, this. Okay? Do not mix log with natural log. Both of them have to have log or both ln. So the answer was negative 0.56457. 5. Good. Going back. Let me share. Good. Back to the book. Here it is. Good. It was a very good pick. So I already gave you an example here. Natural log. These we know how to calculate natural log, how to punch it in the graphing calculator. We're going to look at the graph of natural log in a minute. We just solved exponential equations. Let's see if we want to solve another. Anything from 39 to 50. We just solved one with a doubling time, which was 15 point something years, 0.4. Now let's see if we want to solve any other exponential equation. We got the idea, but you may say, nope, I want to look at another. So tell me if you want to pick another from 39 through 50 to go through the process of solving an exponential equation. And then we will graph log and look at other examples. So, do we want to solve any other, 39 through 50, or we move on? Anyone, ladies and gentlemen, please?
Can we do 45 and
Yes.
49?
Yes, 45 and 49. Perfect. So let's take a look at 45. In 45, we have e to negative 0.02t equals 0.06. I'm going to copy 49. It's easier if I copy it here. 200 e to 0.045t equals 600. Perfect. Good. So let's start with this. Since there is no simplification necessary or possible, what would you do to solve this equation for t? What do we need to apply to both sides of this equation? Keeping in mind that the base here is e.
Natural log.
Yes, thank you very much. Awesome. So we have natural log here and natural log here. Based on the properties of the natural log, how do I simplify this? The left-hand side. The right-hand side stays as this, and there is nothing I can do here. But how do I simplify the left-hand side? But that's the reason why we applied natural log, to be able to simplify. We need to apply one of the properties of natural log, or log in general, which is how do we simplify this? What should I write here?
Negative
Yes?
0.02 times t.
I should write times natural log e. Why I will not write natural log e is because natural log e is exactly. That's it. Good. So now can anyone tell us how to find t? And that will be the last step. And then we will find t. How do I solve this equation for t?
Oh, just divide by
Yes.
points.
Yes.
Points.
Yes. Good. So let's determine that. Awesome. Thank you very much. So we have natural log of 0.06. Close. Divide. Please put parentheses because it's a negative number. 0.02 and close and press enter. 140.67. So t 140.67 approximately. Perfect. Now let's look at 49. Any questions on this? Does it come back to you from college algebra? So here we have 200 e to 0.045t equals 600. We have to clean it up first. We have to simplify it. Or I'd like to say clean it up. Simplify it. Is there any way I can simplify it? Can I simplify?
Divide by 200.
Very good indeed. Divide both sides by 200, so I have e to 0.045t equals 3. Now we're back to the same procedure. Exactly what we just did. So how do I continue? What do I apply to both sides?
Natural log.
Yes, thank you very much. We apply natural log to both sides. How do I simplify the left-hand side? Anyone, please? Let's finish it up and move on. What do we have on this side?
0.045t.
0.045t. Why don't we write natural log E? Because I would have written times 1. Yes, indeed. So then t from here would be what do I write?
Natural log 3
Very good.
over 3.
Excellent. Great job. Let's find it quickly. So I have natural log 3 and divide by, I didn't need parentheses because I don't have a negative number. So it's 24.41. So t approximately 24.41. Good. Back to the book. Okay. So yeah, no, I would like to graph the natural log. So discuss a little bit natural log, and then we'll come back to those equations and domain and everything. So I am on page 5. So if you remember, at the beginning of the class tonight, we graphed the exponential functions. And we graphed the first one. I need more colors. Okay. So we graphed the first one. This. It's an exponential function with a base greater than 1 or less than 1. Greater than 1 or less than 1?
Greater.
Yes, this is greater than 1, increasing on all its domain. When we graph a function and its inverse on the same coordinate system, we first have to graph a line that is y equals x. And then basically reverse the graph over that line. So if this is the exponential function with a base greater than 1, this will be its inverse function. And that inverse function is log base a of x, with a, of course, still the same, greater than 1. So now if I ask you, find the limit as x approaches infinity from log base a of x, what will you say? And I will ask you also, limit as x approaches 0 from the right, from log base a of x. So, as x approaches infinity, the function values go where?
Infinity.
Thank you very much. Great job. Now, as x approaches 0 from the right, the function values get closer and closer, closer and closer, closer and closer to what?
Negative infinity.
Thank you very much. Which means this line for this function represents what? How do we call it? What do we mean by VA?
Vertical asymptote.
Thank you very much. That's it. So this is the graph of the log function as well as natural log, as well as common log. Notice that common log does not have a base. We know it's 10, but we don't write it. Natural log doesn't have a base, but we know it's e, but we don't write it. Both these functions will have the same shape because their base is greater than 1. Notice there is a problem with this function. This one there is no problem. Its domain is all real numbers. But what is the domain of this function? For natural log, look at the graph and discover the domain, please. What will be the domain of this function? Domain, not range. Can anyone give us a domain?